Live. Okay, so today we want to talk about what they call the nature of roots. Oops, 10. Now the roots are the same thing as zeros. And we find zeros by p of x equals 0. So they're any, oh my gosh, any value that makes p of x equal to 0. Those are our roots. And there's a bunch of stuff we already know. A ton of stuff we already know. I'll let you get caught up and I'll show you. So like Lauren said, if we have p of x equals some x to the n, then we know there's n number of roots. It's the same as the degree, right? The degree tells us the number of roots, okay? We know that. If it's to the fourth power, there's 4 roots. If there's a third power, we've got 3 roots. If it's to the fifth power, we get 5 roots, even including double or triple roots, okay? We know that. Complex conjugates, like Ellie said, they come in pairs, right? So if you have an x, if you have an a plus a bi, then we know there's an a minus bi. We know that, right? They come in pairs. And same thing with the square roots, right? We have an a plus the square root of b, then we know there's a pair of them. There's an a minus the square root of b, right? We know these. These are things that we definitely know. This is what we just talked about, okay? This is what the theorem says. And then odd, even roots, we know if it's odd, an odd polynomial always has one real root. No matter how you draw it, always going to have 1, okay? In Theorem 5, we just looked at Theorem 5, and it talks about the sum or differences, right? And we saw that for the sum of roots. So if you happen to know the zeros, the sum of the roots, if you know the sum, you just add them up. But if you don't know the sum, you can at least find out what the sum is by negative a of n minus 1 divided by a of n, which is the second last, it's the second number, which it's the negative of the second divided by the first. What does that tell you? Only what the roots add up to. You may not even know the roots. You may not even know the roots, because if I were to throw this problem down right here without factoring it, you don't know the roots, but we can find out the sum of them and never know what they are, okay? And then the product, whether it's odd or even, is going to be the a of 0 divided by a to the n, or it's going to be negative a of 0 over a to the n. Yeah, there you go, Laura. And that's if it's even or if it's odd, okay? Today's homework's going to ask us some of this, which shouldn't be too hard. I was impressed. You guys were reading that math book pretty well. I was very impressed. Yep. Right. I will tell you, I had one class where I had to read one page several times, every time I read this math book, because it was hard. It took me like 5 minutes per page to read this darn math book. True story. And true story, I think I failed every single test in that class and got a B. I'm like, what? And then I talked to some of the other guys, and I had the second highest F in the class, so the professor couldn't fail us all.
Was the class where you had like, it was like the new math?
Yeah, it was this, it's called Abstract Algebra. It had nothing to do with algebra. No X's, no Y's, nothing. It's just groups, rings, everything. It's like, and then it was invented by like a 14-year-old genius. Yeah. Yeah, and I'm not a 14-year-old genius, not even close. So.
You know, when I was working, I was a 14-year-old genius.
Of course you are.
Someone could shuffle the cards and not even show me, I would know the list of them.
Wow, really?
I'm just kidding. Those
Okay.
are all a lie. Don't believe that.
I almost did, Carly. What does that tell you, huh? Yeah.
That highlighter.
It's right here. Was this yours?
That's mine. I forgot. I couldn't.
Perfect.
Mr. Ames is the same exact highlighter.
No, I was here this place. It's yours. Okay, now, so every quadratic will always have, for every quadratic will always have roots of this. And make sure, highlight that, circle that, and I'll show you how this works, okay? All right? And it comes from that theorem about the sum and product of roots, okay? How is this formula going to help us? Well, let me give you an example, okay? So example 1, if x equals -4 is an answer, and if x equals 3 is an answer. Now it says find an equation of a quadratic, because there could be lots of them, but one of them could be as simple as p of x equals x plus 4 times x minus 3. Right? I mean, these numbers came from our mini equation. If there's zeros, then we would have set it equal to 0 and solve. Okay, thumbs up on how this equation can generate these two zeros. Does that make sense? Okay. Now, example 2. We're not going to do example 2 like this at all. Because one way you can do example 2 is this. You could, and I'm doing it in this way so you don't write this down. You could say x is equal to 2 plus 3i, right? And the other would be, x equals 2 minus 3i, right? Okay. And if we did the same way, we could say, okay, p of x equals, let's see, I'd have x minus 2 minus 3i times x minus 2 plus 3i, right? If I do it the exact same way I did up here, and then I'd have to simplify this because that's a mess. This will work. You okay on how I got that? These are the answers, then it came from many equations with this one. That's a mess. So if we go back up to that formula I showed you, there's a faster way of doing this, okay? Because we're really not going to do it that way. No, don't. That'll work, Jose. That particular method will work. That's doing it the long way. So let me show you these ways. So taking together what we learned about the sum and product of roots, we're going to use this formula right here. So if it's a quadratic, if it's an x squared, if it's a quadratic, if it's an x squared, we're going to write p of x equals x squared minus the sum times the x plus the product. Okay? We're going to use that formula. Now we do know there's two roots. You've got 2 plus 3i. And Tanya, yes, we have 2 minus 3i. Awesome. We need both, don't we? Right? So when it says sum, it means just add them up. So a little side work. Sum of my roots. Take these two, I'm just going to add them. Sum. So I'm going to go, okay. 2 plus 3i plus 2 minus 3i, and I get 4, don't I? I get 4. So my answer so far is p of x is equal to x squared minus 4x. And the product means to multiply, right? Okay, so I'll do a little side work. Multiply these two, okay? So multiply these two, a little side work. I'll take a 2 plus 3i times a 2 minus 3i, and I'll multiply. keep in mind, I squared is negative 1, right? I squared is negative 1, right? So I'll get 4 minus 6i plus 6i minus 9i squared. 4 minus a negative 1, because I squared is negative 1, or 13. So I get 13. So this x squared minus 4x plus 13. You'd have to use the quadratic formula, right? When you use the quadratic formula, guess what you pick for answers? Those two. You don't really want, I mean, I could, but I assume you believe me, right?
Yeah.
If you took this and you use quadratic formula, these will be your two answers, okay? Right. Next slick?
I don't know if I'm.
Go ahead. So let's take a look at the next one.
I'm good.
Now, Jose, what you wrote down will also work. This is faster, isn't it?
Yeah,
It's really easy, right? Okay, now, example 3. If it's a cubic, then we should have 3 zeros, right? 3 roots. We do have x equals negative 2. I have x equals 1 plus the square root of 3. And what's my other? Yep. 1 minus the square root of 3. Everybody agree with that? So I'm going to have for sure x plus 2, right? These two together make an x squared equation, right? So why don't we use our cool little formula to get the quadratic that make these two. So I'm also going to use x squared minus the sum of my roots plus the product, okay? The sum, that's easy. So a little side work. So the sum's going to be 2, right? Isn't the sum 2? The sum is 2. So I've got p of x equals x plus 2 times x squared minus 2x. The product, let's see, I'll squeeze that down here, okay? Plus the square root of 3. Okay, so I'm going to find out what the product is right now. So I'm going to multiply them out. One minus 1 square root of 3 plus 1 square root of 3 minus the square root of 9. Okay, I'll wait for you. Which is 1 minus 3, which is a negative 2. And you can try it out. I'm going to just assume you don't need me to do this, but if you were to use the quadratic formula on this, you would get these two answers. Okay? All right, so homework is a hodgepodge of this stuff.
Would you just simplify it all, like do x plus 2 times x squared?
The book does. Okay, Lauren asked a really good question. The book likes to simplify. Don't. I'm going to say please don't. I know myself. What am I going to do? I have the right answer. What am I going to do? I'm going to foil it out and I'm going to make a mistake. I'm going to get it wrong. Right? That'd be me. So I'm saying if you have one form that is correct, just stop. Yeah. Because I know Lauren probably, if I'm going to do it out, I'm going to make a dumb mistake and I'm going to have the right answer and get it wrong. It's like, no, leave it there. Okay, so here's our homework. You guys, I know you need to work on your balloons, right?